All right. Welcome. You're now ready for the Mississippi River Project. Okay. So we just get right to it. Okay. No FaceTime with me this time. We're just going to go straight to it. All right. All right. And make sure you have the Mississippi River student document loaded up on your calculator so that you can follow along with this video. Did you know that the Mississippi River touches 10 of the United States? It is the second longest river in the U.S. with a length of 2,340 miles from its start in Minnesota to its mouth in the Gulf of Mexico. We all know that water takes the path of least resistance, which usually means it flows downhill from a high elevation to a lower elevation. This means that the water flows over a slope. Since the Mississippi River is so long, we cannot assume that it has the same slope for the whole distance of the river. Rather, that the river flows fast in some parts and slow in others. It will be your job today to discover the fastest and the slowest parts of the Mississippi River by using your knowledge of slope and the information provided on page 1.5. For example, here is the information that we have here. Twin Cities is at an elevation of 834 feet. Traveling on to La Crosse, La Crosse has an elevation of 654 feet. And the distance between those two cities is 144 miles. And so on and so on and so on. So we're going to use this data in order to calculate our slopes. We have a rise and we have a run. So this is what we're going to do. Step one, use the data provided on the worksheet. And by worksheet, we're really talking about page 1.5 to calculate the slope between each pair of cities. Use your calculations, page 1.7, to show your work. Is that right? We'll see. All right. Anyway, we might skip 1.7. We have to see. All right. So the slope, of course, is a rise or the run. We need the change in elevation, and we need the miles between the cities. Note that since the elevation is always decreasing, all the slopes should be negative. So what we're going to, and first of all, let's calculate the slope. All right. So let's look at problem number one. Let's see. Let's say we wanted to get the slope of the first two cities, between the first two cities. Our rise is going to be 834. So that we'll make it negative, we'll go 651 minus 834. We'll do that. We'll let this La Crosse be the Y2s, and we'll let Twin Cities be we'll let that be Y1. So let's go ahead and do that. For example, if we were doing La Crosse, and I'm going to actually put an extra step in here, insert comment. Let's lose Twin Cities. Got to spell it right. Twin Cities and La Crosse. Suppose I wanted that. I don't think I spelled that right. La Crosse is spelled with an S in there. Okay. All right. By the way, I used menu 1.6 in order to do that little comment there. Okay. So let's press enter and let's calculate the slope. We need a fraction. We know we'll let Twin Cities, let's subtract 651. Let's subtract 651 minus 834. 651 minus 834. And what is our distance between those cities? It is 144 miles. We don't have to calculate it. They gave it to us. So, all right. If we do that and we press enter, we get our first answer there. Okay. So, and I don't know why I accidentally, let's get rid of that. Now, let's do the next cities. Okay. Um, let's look at La Crosse and Dubuque. And I'm going to insert a comment here. So menu 1, 6, and now I got La Crosse and Dubuque. Let's make sure that I spelled this right. Yeah, La Crosse has a big C there. So I want that to be a capital C. All right, got that. Let's press enter. And let's find its slope. Okay, so we're going to go with, well, let me go back to 1.5. I need 620 minus 651 over 129. I've already used the 100. The distance between La Crosse and Dubuque is 129. So, and their elevation is 620 over 620 minus 151. So let's go. I didn't say that right. But anyway, let's get a fraction. 620 minus 651. Okay, and all this is over 129. And press enter. And there is my second slope. So as you can see, we are calculating these slopes. Okay, so calculate the remaining slopes for the rest of the cities. And that'll be, and that's what we'll do on page 1.7. Okay, so you'll finish that. Okay, you can stop this video while you get the rest of them. All right, now let's go to step 2. It says enter the elevations of the cities in order into the elevation column in the spreadsheet on page 1.8. So basically we're going to let this check our information for us. Okay, so let's put in our elevations. Let's see, let's go to 1.5, and our first elevation is 834. So I'm going to go 834. All right, looks like I'm gonna have to print this paper out. And our miles between, let's see, we don't have any miles there, so we're gonna put 0 there, because, all right, we won't have our next elevation. If we go to La Crosse, 651. And we're going to put in, what's our first elevation, our miles there, 144. So 144, press enter. All right, and I'll do one more. Okay, let's go ahead and let's put in our next elevation. That's 620 and 129. 620 and 129. All right, press enter. Got that. Now, okay, what we're going to do here is, I said, once we put all the elevations in, you go ahead and finish all those, put those in there. So I just did 2 and 3. Now you finish those for all the cities. Then next, we're going to calculate the cumulative miles by placing our cursor in the formula cell of column A, and then pressing menu 371 variable, then select miles and press enter. So let's do that. We're going to put our cursor again in the formula cell, column A, menu 371, and then variables. So let's do that. Let's go, let's make sure that we're there. Okay, in the C miles column, yes I am. All right, so menu 371, that's right, that's what I want. Var, and I want miles, right there, miles, and then I press enter. All right, and as you can see, if you're doing your slopes right, all this should agree you see that the slopes pop up as well, and that will check the work that you did on the other page. Okay, so we can get that far. Notice that as you are putting these points in, a graph is beginning to take shape. So um, let's see, and actually I'm not even sure how uh, those names popped up, but you'll get this. Okay, and let's see how far this video is. We might have to stop. As I'm at 10 minutes. Okay, I'm going to go ahead and let you finish putting in steps. Let's see what we got. Let's see. All right, we done 4, 5. All right, and it looks like we won't actually have to do the piecewise defined functions. We won't be doing that part, but we will be doing menu 833 to measure the slope of any segment you place your cursor on. Okay, so we're not going to do the piecewise part. What we're going to do is this. We're going to measure as you get these slopes, as you get these points in, then all we got to do to see which was our greatest slope, all we got to do is go menu 8, 3, 3, and put our cursor, and it tells us what the slope is for each one of these segments. And so as we complete the 1.9, then we will get the answers that we're looking for. Okay, and then we'll just compare the segments and see which one is actually which of the segments has the steepest slope and which one has the smallest slope, greatest slope, and we'll be able to answer the questions on page 110 and 111, and that'd be pretty much it. Okay, so that's enough for you to get started on, and we'll just go from there. So if you have any questions, anything that you don't understand, make sure you ask me in class. Other than that, you really have everything you need to complete the project. This will be calculator only, so you won't be doing anything on paper. Okay, but let me know if you have any questions. So enjoy.